Joining us next on the virtual stage from France, we have Teratonics, and representing Teratonics, we have Marco Cavallari, who is the Chief Commercial Officer and co-founder. Teratonics are developing a novel, non-destructive testing solution that allows to detect defects inside and on the surface of a given object. Marco, thanks so much for joining us today. How are you feeling ahead of your pitch?
Oh, I'm very excited. It is a very big privilege for us to be here.
Amazing. Well, we're really happy to have you here pitching for us today. So same as everyone else, I'm sure you know the rules by now. You have 3 minutes for your pitch. With that, big good luck and off you go.
Thank you, Gemma. Hello, everybody. I'm very pleased to present our company and our technology for controlling the invisible. Why is this important? First, many industries like transportation use lighter and lighter products to reduce their carbon footprint. Second, there are big expectations on quality 4.0 for the reduction of the cost of poor quality, which accounts on average to 5% of the company's revenues, according to AFNOR, the French normalization body. For these reasons, there is an increased need for new innovative quality and process control systems, which can be directly deployed on a production line. They have to be penetrating, contactless, harmless, and rapid. Now, the current solutions on the market cannot simultaneously match all these requirements. Just think of X-ray computed tomography, for example. It is too slow to be deployed on a production line, and it is hazardous, for example. That's why we offer to the market a game-changing solution based on ultra-fast terahertz pulses. It is a fully automated solution. It uses a patented detector, which is 10 million times faster than the state of the art. This is why it can be directly deployed on the production line for dimensional control and defect detection inside electrically insulating materials. Our solution can detect voids, inclusions, density variations, and other defects in plastics, composites, and ceramics. It can also characterize assembly lines in glued, welded, or overmolded parts. It can also be used for the characterization of coatings with a single or with several layers. Our solution can help the automotive industry to save 1 million tons of plastics per year. This is impressive. That's why there is a big market for our solution. It is estimated to be over 700 million euros per year and growing quickly at a pace of 20% per year. What we offer to the market is lab services, on-site inspection, and the sale of equipment through channels for worldwide coverage. Our company was founded 3 years ago, and we progress rapidly. We have achieved a few important milestones, like signature of an agreement, distribution agreement with Drexel, seed funding with Socomore, a few awards, many POCs, half of them being paid. We progress rapidly because we leverage on 10 years of research in the academia, and because we have a strong team of 6 people and more than 50 years of collective experience in technology and business developments. What I'm expecting from this event is to meet customers and also investors for our next funding round. Thank you.
Thank you very much, Marco. Awesome. Let's move on to the judges. Who would like to go first with your question for Marco? Kelly, off you go.
Can you talk more about the saving materials per year? So I think here you mentioned saving specifically plastics, but how does the technology enable that?
It can enable that in several ways. For example, it can enable that by controlling the amount of material that is deposited. For example, if you think of coating, to control a coating, even a wet coat, that is something that is very, if not impossible to do nowadays. So we can do that. So this allows to have exactly the right amount of material. Or it can also enable the use of alternative materials, like I'm thinking of plastic foams, for example, instead of compact plastics. And therefore you have a gain because you have material which has a foam for gas inside, or the use of plastics instead of metals. And the reason why we can enable this is because currently in the industry, there are some concerns about the use of these new materials because people are not sure that they're safe enough. And therefore, they need to be controlled, and they need to be controlled not one every 1 million or offline, but they need to be controlled online, if possible, 100% of the production.
Thank you, Marco. Who would like to go next with your question? Cyril, you just beat Massimo to it.
Now, you've mentioned 3 different types of business models, essentially. Which one do you think is best for the future?
Definitely the sale of systems. However, we definitely see that there is a need for services. So people who might need some support maybe to set up a process. And then once the process is set up, they don't need our system to be deployed on a production line. And then there is something which I haven't mentioned, which is hardware as a service or leasing as an option, which is also something that we're considering for the future.
Thank you, Marco. Massimo, you're up next.
Yeah, ultrasonic defect detection has been around for a while. I'm assuming that it's the frequency level, and therefore you can also detect smaller defects. But again, what's the competitive advantage of the technology itself?
Ultrasounds, as you know, work best if there is a coupling between the equipment and the object you want to analyze. This coupling is a gel, for example, or water. And in many cases, you simply don't want to touch what you produce because you don't want to put any dirt on it. You don't want them to dry it. You don't want to deposit. So that is a first problem with ultrasounds. Secondly, with ultrasounds, it's not that easy to understand the defect that you see because you have a few artifacts because of the nature of the waves which propagate in different directions simultaneously. We don't have that with our system. The waves only go straight, which simplifies a lot of the understanding. And our solution works also on cavities and what do you call that? Nida Bay, structured hollow structures in which ultrasounds do not propagate.
Thank you, Marco. Eugenie, we've got time for a very quick last question.
Yeah, so THC sensing is quite a busy field with more than, I'm just looking online, 25 companies working on it. What's your competitive edge? Why are you so different from others?
On sensing altogether. So we use this terahertz technology, which is safe. It is non-contact. And it can see inside electrical insulating materials. And it is fast. Our solution is fast. So it can be deployed on a production line. And the combination of these 4 factors is something that you don't find that easily. And in fact, we open up a new space for sensing. And many times we talk to customers and they say, let me scratch my head because I've never seen that before. What is this telling me? You see?
Thank you very much, Marco. I'm sorry, we've run out of time. I'm sure we could all ask many more questions of all of the startups, but unfortunately we're going to have to move on to our 6th and final pitch of today. Thank you very much, Marco.
Thank you.